Okay, pre-cal, if you need extra, even and odd examples, I've written out a few here, so I will just work through these with you, and then maybe that will help clear anything up. So the way the question will be asked of you, you will be asked to prove whether or not the following are even, odd, or neither one. So how are we going to jump into proving that? Well, we are always going to start by finding f of negative x, just like I did on those last examples. So everywhere you see an x, you will plug in or substitute in, sorry, that's the right math way to say it. You'll substitute in your negative x, and then you'll just simplify it. So let's do that. So I've got 3 times a negative x cubed. Well, negative x cubed is negative x to the third. So I'm going to reach out and put the negative in front here, since 3 is multiplied by the negative x cubed. And then I've got negative 4 times negative x, which actually gives me a positive 4x. Well, as you can see, f of x, my original, and f of negative x are not equal to each other because the signs are different. So that means that I have a situation that I have to now find negative f of x in order to determine if it's odd. Because if I know that these two aren't equal to each other, I know that I don't have y-axis symmetry and it's not an even function. So now what I'm going to do, I'm now going to find negative f of x, and I'm going to determine if it is equal to this f of negative x that I just found. Because if those two are equal, then I know that I have an odd function. So with negative f of x, I am going to put a negative in front of the original equation, the original function, okay? So, see, I just wrote that down here and put a negative in front of it. So now I'm going to distribute the negative to determine if it is equal to f of negative x. So remember, if f of negative x, remember your rule, is equal to negative f of x, then I have an odd function. So let's see if that is true. Okay, f of negative x is negative 3x cubed, and I just found negative f of x, negative 3x cubed, so that's right. And then f of negative x is also positive 4x. Oh, and so is this. So that means that f of x and, f of negative x and negative f of x are in fact equal to one another. So that means that my answer is that this is an odd function, and that means we have origin symmetry. Okay, so that's how that works. All right, so let's look at the next one. Use a different color here. So I'm going to go through the same process. I want to prove whether or not this function, f of x equals 2x cubed plus x squared plus 1, I want to prove if it's even, odd, or neither. I'm going to start in the exact same way. I'm going to find f of negative x. So 2, use parentheses to substitute in a negative x to the third, plus negative x squared plus 1. Now I'm going to tidy it up. So negative x to the third is negative x to the third. So I'm going to put the negative in front of the 2. That is just appropriate math writing, just FYI. And then I've got negative x squared. Well, that's going to give me a positive x squared plus 1. Okay, so here I've got f of negative x. Is that equal to my original? Well, if you'll notice, the original does not have a negative in front of the 2, and f of negative x does. So that means it's not even. So now I have to try to see if it's odd. So remember how we do that. Now I've got to find negative f of x. So I put a negative in front of the original function. And I'm using parentheses so you won't forget to distribute the negative. So this means that I have negative 2x to the third minus x squared minus 1. So this is negative f of x. Now ask yourself if this is equal to f of negative x. Well, if you'll notice, the signs here are different, so they are not equal to each other. That means we have a function. It's probably not a function, but it's neither even nor is it odd because it doesn't have, well, it is a function, but it doesn't have it doesn't have symmetry about the origin, and it doesn't have symmetry about the y-axis. And if you'll think about this, since it's the cube function, the parent for the cubic function looks like this. So if it moves off that origin, there's a pretty good chance you're not going to have y-axis symmetry or origin symmetry. So keep that in mind. Okay, so as we move forward here, and I'm sorry this video is taking so long. As we move forward, we have our next example. I put this one in here because you've got a fraction in your homework and those freak everybody out. I'm going to go about proving this the exact same way though. So I'm going to start with f of negative x. So everywhere you see an x, you're going to put a negative x. All right, why did I make that a 12? Amy, sorry, Miss Griggs. Sorry about that, kids. Okay, so now I'm going to tidy this up a little bit. So I've got negative x up here. Negative x squared becomes a positive x squared. Okay, so look at this function. Is f of negative x, is it equal to my original? Well, if you'll notice, there's no negative in front of the x in the numerator. So this means no. So this is not even. So now I have to try by finding negative f of x and seeing if that works. So the negative of the original function. So I put a negative in front of the original, and now I've got to distribute it. This is where things get tricky. When you distribute a negative to a fraction, you can either put it in the numerator or in the denominator. So, but you don't put it in both because they cancel each other out. So I'm going to distribute that negative just to the numerator. Now ask yourself this question. Is negative f of x equal to f of negative x? Well, we've got a negative here, x squared. No. Why did I make that a 1? What is wrong with me? Jeez Louise. Ugh. Negative, negative. Okay, so those are equal to each other. So remember, if f of negative x and negative f of x are equal to each other, you have a situation where you have an odd function. That means we have origin symmetry. So hopefully that helps clear some things up and will give you a little bit better understanding of how to prove if a function is even or odd.